Now the geometric sequence, that's an interesting one. That one is exponential. It's got an exponential rule. And I'll show you what I mean. A sub n, and let me write this a lot bigger. A sub n equals a sub 1 times r raised to the n minus 1 power. Now if you remember from the previous video, r is your common ratio. That's your second term divided by your first term, or your third term divided by your second term, or your fourth term divided by your third term. In fact, it's any term divided by the previous term. And in a geometric sequence, that ratio is going to be common. So it's going to be the same thing every single time. It's never going to change. N is your unknown. So n is your unknown. And then a sub 1 again is the value of your first term. So in the previous video, I had given an example of a geometric sequence, and that geometric sequence was 2, 6, 18, 54, so on and so forth. And the common ratio we found was 3, because 6 divided by 2 is 3, 18 divided by 6 is 3, 54 divided by 18 is 3. That means you multiply by 3 to get from one term to the next. Okay, very good. So now we want to write that formula. The value of the nth term is equal to the value of the first term times the common ratio raised to the n minus 1 power. So the value of the first term times the common ratio raised to the n minus 1 power. Sometimes I will write this 2, and then I'll put in parentheses the common ratio, and then n minus 1 on the outside of those parentheses to show that the n minus 1 only goes with the 3. It also discourages me from trying to multiply 2 times 3 first. This right here is your formula. So let's go backwards. If I'm given a sub n equals 5 over 2 raised to the nth power, what is the common ratio? Well, your common ratio is the value that's in parentheses. It's called the base. So the base is 5 over 2. Now, this 5 over 2 raised to the n power, it's 5 over 2 raised to the n power, is the rule. So they've taken away minus 1, and they've taken away a leading coefficient. So for this rule, the value of the first term is equal to 5 over 2 to the first power. So the first term is 5 over 2. The second term is 5 over 2 raised to the second power. So that would be 25 over 4. The third term is 5 over 2 raised to the third power, which is 125 over 8. And the value of the fourth term is 5 over 2 raised to the fourth power, which is 625 over 16. So those are our first 4 terms, and the common ratio is 5 over 2. Now when we are given the sequence, that is typically when we are going to write in n minus 1. And I'm going to demonstrate that for you in that particular problem. So when I put the value of the first term in, so if I put a 1 in for n, I've got 2 times the quantity 3 raised to the 1 minus 1. So this 1 goes right there. okay? Now 1 minus 1 is 0, so that's 2 times 3 to the 0, and 3 to the 0 is 1, and that gives me my first term of 2. So that minus 1 is very, very, very important in that particular formula. But sometimes when they give the formula to us, they give us just the variable and the exponent without the minus 1. And either way is good, but when we're writing the formula, we use the minus 1 because it's much more simpler for us to do that, and we get it right that way. Find the fifth term and the nth term of the geometric sequence whose initial term a sub 1 and common ratio are given. So our common ratio is 4. Our first term is negative 1. So I'm going to write down the formula, and I'm going to use the formula n minus 1 right there, because that's going to be the easiest way for us to write a formula. We want to find a sub n. So a sub n is equal to the value of the first term, which is negative 1, times, and then I'm going to put the r in parentheses, raised to the n minus 1 power. There's our formula for the nth term. Now if I put a 1 in, I'm just going to check my work. If I put a 1 in for n, I'm going to have the 0 power, negative 1 times 4 to the 0 power is negative 1 times 1, which is negative 1. And that gets me back to my first term. And that's how I know that my formula is correct. But we want to find the value of the fifth term. So a sub 5 is equal to the first term, which is negative 1, times 4 raised to the 5 minus 1 power. So that's going to be negative 1 times 4 to the 4th power. And 4 to the 4th power is the same thing as 16 squared, which is 256. Negative 1 times 256 is negative 256. So the value of the fifth term is negative 256. And that's how you write the formula and then use the formula to find a specific term. So let's see how far you can get on this next problem. Find the 8th term of the sequence, 1, 3, 9, and we want to find the 8th term. We're going to try and do this with formulas, so see if you can write the formula for the nth term and then use it. If you're still a little stuck, I'm going to go through this problem. You can hang out with me. Okay, we know that the formula for the nth term is a sub n equals a sub 1 times r raised to the n minus 1 power. We know that the value of the first term is 1. We know that the common ratio is 3 divided by 1, which is 3, or 9 divided by 3, which is 3, because you multiply by 3 to get to the next term. So our common ratio is 3. So a sub n is equal to 1 times 3 raised to the n minus 1 power. Now we can use that formula to find the 8th term. So the value of the 8th term is equal to 1 times 3 raised to the 8 minus 1, which is 3 to the 7th power. And 3 to the 5th power, 3 to the 5th power is 243. 3 to the 6th power, I'd have to multiply that by 3, and I get 729. And then 3 to the 7th power, I'd have to multiply that by 3, and I get 2,187. So 1 times 2,187 is indeed 2,187. 87. And that's the value of the 8th term. So if you got that, you should be feeling really, really good about exponential rules, which are called the geometric sequences. So now you know that we have sequences that have commas, and then we also have series, which is a sum. So let's just pretend that I wanted to add, I'm going to find my first example here. Let's say in the very, very beginning of yesterday's video or the previous video, 2, 6, 18, 54, and then 162. If I wanted to change this from a sequence to a series, I would replace the commas with addition signs. And then I could just add all those numbers up together. But sometimes we need to use a formula to add our numbers because it's not feasible to find all the terms first and then add them up. So here's our formula to find the sum. So the sum formula for geometric series. A geometric series that is finite, meaning it has a beginning and it has an end. S sub n is equal to the value of the first term times the quantity 1 minus r to the n all over 1 minus r. And there's no shortcut, there's no other option. That is the sum of n terms of a geometric series that's a finite series. It has a beginning and it has an end. So let's try and use this formula with this series right here. This series has 5 terms, so that means n equals 5. The value of the first term is 2, and our common ratio is 3. So the sum of those 5 terms is equal to the first term times 1 minus r, which is 3, raised to the 5th power, all over 1 minus 3. 2 times 1 minus 3 to the 5th power is 243, all over negative 2. Now 2 over negative 2 is negative 1. 1 minus 243 is negative 242. So our sum is 242. Now if you take all of these numbers and add them up, this would be 26. 26 and 54 is 80. 80 plus 162 is 242. And that's what we have right there. So the formula works. It's just about how we can use that formula. Now, you can also, with geometric series only, geometric series only, you can find an infinite sum. This only happens, though, when r is less than 1. And I'm going to say the absolute value of r because sometimes r can be negative. So when I say the absolute value of r is less than 1, that means that r is between negative 1 and positive 1. That's what that means. If r is between negative 1 and positive 1, our series converges. So I'm going to say converging series, converging series. If r is greater than 1, so if the absolute value of r is greater than 1, then the series diverges and there is no infinite sum. So over here, when we have this converging series, we can find the infinite sum. And the infinite sum, this formula is even easier than the last. It's a sub 1 over, I should have put that in the middle because it's that easy, a sub 1 over 1 minus r. And you can only use this when you have a converging series. Let me show you an example of a converging and a diverging series. So here we have, let's do something real obvious, 10, and then divided by 2 would be 5, and then divided by 2 would be 5 halves, and then divided by 2 would be 5 fourths, and then divided by 2 would be 5 eighths, and then divided by 2 would be 5 sixteenths, and then 5 32nds, and then 5 64ths. So what's happening is this number is getting closer to 0. Getting closer to 0. Therefore, we call that converging. Now let's say I started with 10 and I multiplied by 2. Multiplied by 2. Multiplied by 2. Multiplied by 2. Multiplied by 2, and so on and so forth. This number is getting further away from 0. Further away from 0. Therefore, this is called a diverging series. And when you have a diverging series, there is no sum. And I'm even going to put another word in there that's not absolutely necessary, but it might help. There's no infinite sum. So there's no infinite sum. So let's find the sum. Let's do a couple of problems here. Let's put it together. Let's find the sum of the first 8 terms. First 8 terms. Okay. Is that going to be s sub n or is that going to be s infinity? Which one? It's not the infinite because it's a specific number of terms. So it's a finite number of terms, so we're going to use the formula for s sub n. And our series is -1 plus -4 plus -16 ... So our first step is to determine a sub 1. Our second step is to determine the common ratio r. And then the third step is going to be to find the sum of the n terms by plugging in our values into our formula. So a sub 1 is -1. R is -4 divided by -1, which is +4. -16 divided by -4 is still +4, so r is equal to 4. So I think that we can plug in our values now. The sum of 8 terms is equal to the value of the first term times 1 minus 4 raised to the nth power all over 1 minus 4. Well, I've got -1 over -3. The negatives are going to cancel out, so I have 1 minus, and n is 8, 1 minus 4 to the 8th power all over 3. Now this became 3 because -1 over -3 is +3 in the denominator. The negatives canceled and became positive. Now 1 minus 4 to the 8th. What is 4 times itself 8 times? Well, I know 4 to the 5th is 1024. 4 to the 6th, I'm going to multiply by 4. This number is going to get big real quick. 0, 4. And then 4 to the 7th, we're going to multiply by 4 again. So that's going to be 24, 38, 16. One more time. 4 to the 8th, we multiply by 4 one more time, we get 16, 12, That's a 25. 85216. 1 minus 85216. It sounds like a zip code. And 85126, I've run out of room, so I'm going to shrink this. (85126) and then subtract 1, I get 85215, and that's a negative, divided by 3. I think 3 is going to go in there. 6, 7, 8, 16, 21. 3 goes into negative 85215. 3 goes into 8 6 times with 2 left over. 3 goes into 25 8 times with 1 left over. 3 goes into 12 4 times with none left over. 3 goes into 1 0 times, and 3 goes into 15 5 times. So negative 6 8 something. I did something wrong. Was that dog barking? Let's see. 3 goes into 8 2 times with 2 left over. 3 goes into 20, and that's a negative. 3 goes into 25 8 times with 1 left over, and then 4, and then 0, and then 5. It was negative 28405. Negative 28,405. And if I take 28,000 times 3, I get about 85,000, so we're good. So that's what our sum of those 8 terms is. Ay, 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 ay. But that's how you use the formula. That is how we use the formula. Now, we'll do one last problem. We're going to find the sum, the infinite sum. Find the infinite sum of, let's see, 2 4/3, 8/9, ... So how do I find everything I need? Well, first, is it converging? So you first need to find out if it is converging. So what is r equal to? R has to be between -1 and +1. So I'm going to take the second term divided by the first term. I'm going to change that division into multiplication by multiplying by the reciprocal of the divisor, and that gives me 2/3. 4/3 divided by 2 is 2/3. Okay, let's check to make sure that this is right. We have 8/9 divided by 4/3. That is going to be 8/9 times 3/2, which is that right? 4/3? 8/9 divided by, I don't know where 3/2 came from. It should have been 3/4. 3/4, that's a 2. 8/9 divided by 4/3 is 8/9 times 3/4, which is 2/3. So my r value is 2/3. So the sum of the infinite series is equal to a sub 1 divided by 1 minus r. This is converging. So the value of the first term is 2. The value of r is 2/3. 1 minus 2/3 is 1/3. And dividing by 1/3 is the same thing as multiplying by 3. So our infinite sum is equal to 6.